array.
Okay. Can be implemented with an array. Or what do you mean by kind of like an array?
So what I know, it's about the first in, first out.
Okay, that's important. First in, first out. Wait, is this correct? First in, first out, FIFO. That's correct.
Yeah.
Cool. And what you said about arrays is also helpful, which is ultimately a queue is a list. Right? Ultimately, a queue is a list of things. Okay. Someone else. What do you know about queues? Anything?
It has enqueue and dequeue methods.
They have some methods. Yep. Thank you for that, Jan. Methods. Enqueue and dequeue methods. What are there other methods there?
Front.
Front or
Top.
or peak sometimes as well called.
Yeah. And it's
how do you spell peak? Like this? No.
Two E's.
Double E. Okay. And it's empty.
Is empty. Cool. These are the basic methods. Yes. Anything else? Anyone else?
You can maybe do size. We should just be getting the length.
Size is a good one. We can have size. Cool. I think I had recently learned a trick here. Yes, this.
And usually we start with the class and constructor.
Yes, usually we'll have a class for this. Also, I wanted to revisit here in the fact that it's a list. That means that we can implement it with anything that can represent a list. That goes to the answer to this point. We could implement this with an array or with a linked list. And in fact, also, as yesterday, I learned with Joanne that we could also use a map to create a queue, but it's just that, or a hash table, but we treat that hash table as a list, similar to the array. We're not going to see that one today, but maybe we'll get to see these two implementations and talk about them. Definitely the array one, because it's the simplest implementation. Cool. Anything else that I may be missing here? Okay. What about maybe some use cases? What kind of use cases do you think about? Anything comes to mind?
I guess standing in line.
That's right. So standing in line.
Like the queue and the event loop?
Say that again.
The queue and the event loop.
Queue in the event loop. That's a smart one. Queue in event loop. Hopefully we can come back to that. I've been thinking that maybe that's something that I would like to do on a Sunday, sort of just looking back at the event loop.
Maria Lisa said music playlist.
That's a very good one. Yes, music playlist. And also this is also similar to, connects back to the list. We should have said, oh, you know what we should have said at the beginning? A queue is first and foremost is a data structure, right? I always like to ask this question, structure. I forgot how to spell. Like this? Right. So if you get asked, what is data structure? What would you say? Anyone? Anything that comes to mind?
A way to organize data, I guess, or lists.
That's exactly on point. Thank you for that. Yes. It's a way to organize information or data. Ultimately, that is what a data structure is. Is the structure in which you organize your data. And then there are many data structures, as is the topic of this class. Each one with its advantages, each one which is used with its use cases that make the most out of those advantages, and each one being able to be used in a scenario. Cool. Yes, the data structure is a way in which we organize data. Some language I like to use is also like the rules of the queue is the fact that you can only look at the front and add stuff in the back. You cannot look at something that's in the middle of the queue, or you cannot remove something from the middle of the queue, etc. So, and the thing is, like, those rules, we have to sort of enforce them, because really, once we implement this with an array, nothing is preventing us from going into the middle of the array and removing something from it. But if we want a queue, we shouldn't do that, and we will have to respect sort of those rules. That's something that I've seen just common. I did it on my time as well, of just sort of ignoring the rules of the queue and then doing anything with the array just because it's an array and I know how to do things with arrays. But you know, the rules are also attached to the methods. The fact that when we enqueue at the end of our queue when we dequeue, we dequeue from the front. Cool. Okay, so let's take a look at this here. So I think we talked about most of this already. Waiting in line, I was thinking about a use case that it will be interesting to implement, but maybe that can be a backend kind of challenge that I was brainstorming. And a use case I was thinking about, a queue could be, if in your backend servers, let's say the server could detect if it's under a lot of load, and if it is, then instead of responding back to requests that are coming in, because it's not going to be able to respond to them, because it's overloaded, maybe you could save those requests into a queue, and once the server is a bit more free, then starts processing stuff from the queue and prevent it from ever being really overloaded, but by keeping things in the queue. That could be another use case there. So it's like a let's say something like the task queue on the server. We have to minimize this. Cool. Okay, any questions or thoughts up until this point? Okay, so I think we get the idea. So just again, if we visualize a queue, when we dequeue, we remove from the front. So in this case, Ray, which was at the front, Ray was the first one to arrive. If we dequeue that will be removed, and now sort of the front of the queue will become Brian in this case. And then when we enqueue, that goes at the end. So here we see that Vicky arrived, and therefore it goes all the way there at the end. These Zoom controls are getting on the way. Cool. Cool. I think we have this. We talked about the methods. Oh, one interesting thing that I missed on the other side is enqueue should take a value. Let's think about those here actually. Enqueue. Enqueue takes a value. And what should enqueue return? What do you think? Anything that comes to mind?
It doesn't return? No.
It doesn't return anything, right? If I ask you what does well, actually this does have something, but we don't think about it much. What does array.push return?
No.
The array?
Jonathan, what was that?
The end of the array?
What do you mean by the end of the array? Be more specific.
Array.push pushes value to the end of the array.
That is right. That's what it does. But what does the method return? Maybe Nilber.
Oh, the array line.
The new array length. So in this case, we are the engineers of implementing this queue. We could have the enqueue method return undefined or return nothing. Or we could have it return the new length of the array, like in the push method for arrays. It's you know, the push method in the arrays is something that we don't really use much, but it's something that's there just in case. Okay, so let's say we want to just return undefined in this case. Dequeue, what should dequeue return? Should it return something? Anyone wants to jump in?
It should return the first element, the element at the top front of the list.
That's right. Element in front. And oh, I guess like we're sort of talking a little bit about what they're doing. Yeah, it should return the element on the front, and it should remove the element from the front, right? So, in fact, I'll make this a bit more. Peak, same thing. Oops. element in the front is empty. What does this empty return? What type of data?
Check if there is no length or there is no.
But what should it what more specifically, what does it return? What type of data?
Boolean.
Boolean, yeah.
A Boolean. Boolean. A friend of mine used to call it Boolean. And yes, a Boolean, whether or not the queue is empty. Let me minimize this. Okay, cool. And size should return just a number. Number of elements in queue. Cool. Okay, so we get clarity on that, then we're going to jump into the specifics. How to do that. Also, I wanted to say this is true if you haven't realized it yet, really starting to see it. Queues is also a queue is also it's an abstract data structure. I'm gonna add this here, abstract. What does that sound like, or what does anyone want to try to guess what that could mean? Abstract data structure.
Meaning maybe that it exists, but it's not really there.
Yeah, okay, that's a good one. Thank you. Anybody else wants to attempt? So yeah, along the lines of where she says like it exists, but it's not really there. I like that way of putting it. Is not really there by default, right? Like JavaScript doesn't come with it, and even other languages that sort of come with it is because somebody created it and then they and they made a library that just comes with the language. What are known as standard libraries. Many languages like Java come with a standard library, which is, well, I guess JavaScript also comes with a standard library, but in this case, ours doesn't have a queue data structure. But just to put a bit more context on that, an abstract data structure also, yeah, it means that underlying or that computers don't implement queues sort of natively. They don't exist. So if we go back to what we were talking about last time, and we were looking at dynamic arrays, and we sort of looked at a chunk of memory. That's really everything the computer has, right? And just memory and ones and zeros, right? And we learn how an array is stored there, but there is no concept of a queue. The engineers create something on top of sort of that memory, and that is an abstract data structure, something that has some rules, has some methods that that then sort of talk to the lower level on the memory and the array in this case, but it doesn't come. Somebody had to create it. It doesn't come by default. It's like another way of putting it could be like, yeah, like you just in a system you just have a memory and that's it. And arrays are built on top of memory, objects built on top of memory, linked list, all of that are abstract data structures. In fact, I feel like I struggled there a little bit. Let me abstract data structure. Because I feel like this is an important part. Yeah, and I guess this part will apply. It describes a container which holds a finite number of objects where the objects might be associated through a given binary relationship. But that's a bit too mathematical model, and we don't have to get into that. I think we had something here. Let me start here really quickly. Yeah. Let's take a look at this one. Oh, but is this when? Yeah, it's something that is built on top of native data types. Yeah, and this is also it helps us deal with the big picture without having to get lost into the details. Okay, so let's go back here. Cool. So an abstract data structure is the other thing that I wanted to add there is really an abstract data structure is an idea, and then this here, what we're going to implement is the idea of a queue. And most ideas in computing we take from the real world. This is a prime example. Queues exist in the real world. I wonder if, yeah, they actually, you could say they exist in the natural world. I was thinking if it's something that we humans invented, but maybe there is, I'm sure there is examples in the real world, in the natural world. I was thinking about like, you know, sort of a queue of ants that are traveling. They travel in a very organized fashion. But I'm sure there's also some better examples in the natural world. But it's this idea of you put things in the back and you remove things from the front. And how we implement that idea, the specifics, the details can vary. But as long as we respect the rules of it, it doesn't matter as much how it's implemented. So that's sort of the fact that that's what I meant with abstract here. That the details can be different, but we agree on some rules that we respect, we keep, and that make it helpful. Cool. So linked lists are another example, abstract data structures, etc. So let's go. So let's take a look at this queue implementation. So there are many, as I said, there's many different ways in which you can implement a queue. You could use an array, a linked list. There is a double stack implementation as well. Here, this is the simplest one, and is using an array. So we are going to sort of under the hood use an array to keep track of the elements that we have. And then, but we still want to have this idea of adding to the front and removing, removing from the front, adding at the end. So we are very familiar with arrays, I hope. And if we want to add something at the end of our list, we just know that we can push. So literally our method will be just to enqueue something, we just want to push onto the array. To dequeue, we want to remove from the front. What's the method that we use for removing from the front of an array?
Shift.
Shift, that's exactly right. So this is what our dequeue looks like. This is that array that shift. very simple, and it's also, since this array.shift already removes the element out, removes and returns the element that is removed, we can just do it here in one line. Pick, we want to be able to get the element at the front of the queue, and now because we know how the queue is implemented under the hood, how would we access the element at the front of our queue?
Get the index 0 of the array.
Index 0 of the array, that's exactly right. So to pick, we just have a variable, the first index. We don't even need the variable in this case. We can just say this data array at index 0 that returns the first element of the array. Is empty, we could just check the length of the array to see if it's 0. If so, then it's empty. And I guess we didn't have here the size method that we were talking about, but that one, we already have a data structure that does that. We have the array, which already keeps track of the length. And we could just return that. Okay, so as an exercise, what I would like you to do in 5 minutes is to type this out. You can copy and paste it, but I will advise against that and add the size method. So it can be in a REPL or in VS Code. Type this out. Type this class of a queue out, and let's try it out. We're gonna stop sharing. And let's do 5 minutes for that. And I stopped sharing, so I'll say try to do those as much as possible from what I just showed you and what you remember from what I just showed you. But the link is also in the calendar invite for the lesson. Cool. Give me a thumbs up once you have your queue written. Cool. See you, Jonathan. Thank you. Jihan. Yeah, I recommend you do, you know, I feel like this is something we should be able to do in our slate. Implement a queue, for example, implement a stack, implement a linked list even. Are things that we can just memorize, and muscle memory. You know, I'm a strong believer of it. And by that, yes, those are the tiny muscles you have in your fingers. Cool. Oh, I see Maria Lisa. Okay. So let me know if we should give more time, because we're gonna need the queue for the problem we want to look at. Cool. See Nilbert. Thank you. Okay, so I think I saw most of you. Do we need more time? Does anyone need more time? Cool. Oh, is that you need more time, or is that you have it?
No, I have it.
Great. Cool. Awesome. Okay, so okay, let's let me share my screen here again. Can everybody see this? Is it too small, or is it good enough? Good. Okay, cool. I feel like I can add a little bit. I just don't like to scroll that much. Okay, so let's say we want to, oh, you know what I can do? I think I can do this. Yeah, I'll put it in two places and then I scroll down in one. So this is just the below the queue. So we want to create a queue now, and we want to sort of forget that under the hood it was implemented using an array. Right? But then how do we create a queue now? We wanna create this queue object that represents a queue. How do we do that? And what's maybe a key word there that we might hear in the JavaScript world for doing that? Now I want to create a queue called my queue. But how do I create it with the blueprint of the queue?
Use the new keyword.
We use the new keyword. Okay.
New queue.
New queue and zoom still in my focus on the keyboard. New queue. Okay. Like this.
With the parentheses at the end.
Okay. Great. This is, I guess, a general review as well. What does the parenthesis do? Anyone?
It starts the queue, like it initializes a queue.
That's correct. That's correct. That's what it does. More specifically, though, it calls the constructor. So you see, the constructor is a special name function. If we look at it, it looks like enqueue. It's just that it has a special name, constructor. So constructor is a special function that sometimes we just forget that it's, you know, we always write it at the top, but it's still a function, right? And then this parenthesis, that's what it will do. It will call the constructor function. And the new makes the instance. So here, this is also referred to as creating an instance of the queue. That's important language to remember. Creating an instance of the queue. So some people will ask you, instantiate a linked list. And then when they ask you to instantiate, they mean create a new linked list or create a new something. So instance, instantiating are the words for this. Okay, cool. Now, let's say we want to add, let's say we want to add the names of everyone who's in this Zoom room to this queue. How do I do that?
My queue, push.
Okay.
Oh, NQ. Yes, in this case.
Cool. And queue. And since you were first, Joanne goes first. Cool. Who wants to enqueue next?
My queue that NQO.
Cool.
Jonathan.
Is that, oh, and are you enqueuing Jonathan?
Yeah, I'm okay with Jonathan.
Cool. Cool, and let me just add everyone else very quickly. Maria Lisa, do you put your name together or separate?
That's my name.
Cool. Then Sihan, J Jones, let's do J, Shia. Cool. And I guess I'm gonna put myself at the end. Great. So then we enqueued how many? 11. 11 people in this queue. So also, oh, another cool thing is like, what happens if we console log this here? If we console log this here, does anyone want to guess what we're gonna see? What would we see? Let's say call QJS. Jay.
I want to say like either like array of names, I believe.
An array of name. Let's take a look.
Yeah.
You see an array of names. That's right. Inside an object. And the type of that object, or the or this, we will say this is an object of this is an object instance of a queue. This is the constructor we use to create this object, right? The queue constructor, and that's what we have here. So an idea that just came to mind was like, well, console log shows the internals, but what if like we wanted to come up with our own internals, or with our own way in which a queue should be printed out? Well, since we are the engineers are creating this queue, we're respecting the basic rules of it. We could add another method here. I'm gonna call it to string. And here, oh, this is an interesting exercise here. Let's say, or actually, let's say we want to call it print. And let's say we want to create a function that will print the queue in this format. For the queue that we have, then that will be maybe something like this. Joanne, because she's first. Then narrow says Owen is after that. Jonathan is after that. Maria Lisa. And so on and so forth. How could we create such a function that returns, when we call print, it prints the queue in a more queue-like representation? Anyone?
Iterate.
Okay, so iterate through the queue. Actually, you know what? I feel like this is an exercise that I wanna give you, and it will help us to think of two things. Okay, so let me see. I can share this in the chat here, so that you don't have to type it. There is no shortcut for the chat. So here we're gonna do something first. Before putting the function here, I want you to write this here. So outside actually, and I'll give you some time to do it. So we're gonna write a function call, and then maybe after that we move it inside. Const print queue. This function is going to take in a queue, and it should return a string in this format. So takes in a queue instance, queue as an argument, and returns a string in the format below. And I guess I need to do this proper JavaScript. Okay, so also I just want to say be careful here on the iterating through the queue, but I still want you to go try it out. The main thing will be get it to work to console log something like this, actually to return a string that looks like this, given the queue that we have. And then let's talk about it at the end. Sounds good? Sounds like we know what we need to do. We take in a queue. The way in which you're going to call this is I'm going to say print queue, and I'm going to pass in my queue. Let's call that fellows instead of my queue, because we now know that this queue is for fellows. Oh. And that's what I did this wrong. Then bugs start to happen. But I'll work on renaming it. We want to implement this function. Implement a function that takes in a queue, in this case a queue of fellows, and it should return a string that looks like this. Cool, I see your message, Mary Elisa. No worries, thank you for letting me know.
Night.
Good night. Let's take maybe 5 minutes to do that. Oh, and also something that I should have said at the beginning was try to do this. Try to do this without breaking the rules of the queue, which means without only using these methods that you have here: enqueue, dequeue, pick, and its empty size. Try to do it only using those methods instead of accessing the array directly, and then we'll talk about it. Cool. Let's do 5 minutes for that. Cool. Give me a thumbs up once you were able to get the string. Okay, one more minute. Okay, how did it go? Thumbs up or the surprise face? What's the name of that emoji? Oh, I guess I can't see them here. Yeah, that one, Jonathan. Yes. Okay. Did anybody got it to work, or does anybody feel like it's close? Okay, give me a thumbs up if you attempted it. If you did an attempt. Okay. I see a very few of you though, but I appreciate the honesty. Okay, so does anybody want to share how they were thinking about it? And yeah, or maybe what were some of the stuff that you bumped into? Let me see from the people that did the thumbs up. Maybe Nilber, how did it go for you? Like up to what part do you get?
I think I did it wrong. I did it as a method in the class.
Oh, that's okay. But how do you iterate through the queue?
I mean, you can use. I mean, I didn't do any iteration. I just use a join, but you can use like a while loop or something like
see.
that. Yeah.
Oh, I see. You did join. Okay. Okay. That's cool. That is. I actually hadn't thought about that. That's cool. So I assume like I guess we could do something like this. But we'll see. We'll see why this is not. This will be. It's not that it's wrong, but it will be breaking the rules of the queue a little bit. So imagine I imagine off of what Nilbert said, it could look something like queue the array, because we know that it has an array inside, that join with these arrows in place here. Okay. And then maybe we can just say console like this. Something like this.
Yeah.
Cool. Let's take a look. I think this gets the job done. Where did my terminal go? I guess I closed it. Node queues. Nice. This printed our queue in a nicely formatted way. Great. Okay. This does get the job done, but I want to force you to think about doing it without touching the array directly, and only with enqueue, dequeue, pick, or empty. Anybody try to go that route? And thank you, Noble, for sharing. So if we can't touch the array directly, we can only do it through the methods we define. What does that hint to us to do?
Well, we're gonna iterate through the while loop. Then we'll have to iterate until that is empty. Using the method is empty method, I guess.
Okay, yes. So guide me through that.
So you could have a while loop.
Okay.
And then you could put not, and then use the queue and check if the queue is and it's empty, the function.
Okay. Okay. So we're gonna loop until the queue, as long as the queue is not empty. Okay. Anything else, or anyone else wants to jump in onto what you're taking it from where Joan is going?
Yes, we like dequeue each element, but I guess we have to console log it though also. So maybe we should save. Can we save the q.dequeue to like a variable?
I like that idea. Yes. So let's maybe do this for now. Let's say we're gonna dequeue it into an element variable.
Yeah.
And this is what you were saying, dequeuing, right?
Yeah. So then when we actually dequeue, we can save we have some of the console log, because all it does is return the shifted not shifted, sorry, the last element or the first element.
The first element of the queue.
We want to like save it to an element so we can console log it.
Okay.
Is that enough for the print, or do we have to like do what we did earlier and put it all in one string?
It should all be in one string in one line. Yeah.
All right. So then maybe we should start with an empty string outside of the while loop.
Okay. Tell me, what do you want to call that?
I'm gonna call that empty string. No, I'm kidding. Just string.
Okay. And that starts with an empty string, you said. Cool.
Yeah.
Okay.
And then okay, while the queue is empty, let element equal to queue.dequeue. And then we should so we can add the we add the element to the string
Okay.
with each iteration. So it should
And
be element
how do we do
equals
that?
element plus string.
Like this?
Oh no, sorry, I want to do the plus equals. I forgot what that's called.
Oh, what is the plus equal call? Anyone?
Concatenation.
Concatenation, that's right. So what do we type here in this line?
So string equals or plus concatenation plus equals element.
Okay. Do we, okay, do we want to do anything else here?
Let's see, at the bottom we should return, should we return? Yeah, I guess we're going to return the string.
Okay. Great. Anything anyone wants to add or comment on? Let's try it out. Node Q. Okay, we're almost there. We need to add these sort of nice arrows.
Should we?
Let's just do it here. Element plus equal the arrow like that.
Okay.
And then let's see now. I guess this will have. Oops, where did my windows go? Nice. And this has this last one arrow, which we could get rid of it, but this is good enough. Cool. Okay. Okay. So now we have a way to sort of, this is we created our own visualization of the queue, and that's totally fine. Like we're saying, oh, this is the way we want to print a queue instead of looking at sort of the internals. And this will be fine in our case. Cool. So now we know how to print a queue. So what would we have? Let's say we are printing the fellows queue, and that works. Now, what if we want to say after that we want to say fellows enqueue. Who do we want to enqueue? Let's enqueue Corey. Well, Corey is not really a fellow, but who do we want to enqueue? Let's enqueue JR. He was a fellow. We all know JR. And then after that, we wanna print the fellows queue again to see now JR should be at the end of the queue, right? And that will be after Alejo. So let's take a look. Well, I guess it's kind of hard to see. Let's say console log enqueue JR to tell it apart. So that we have it. Enqueue and we have our initial queue. which was this, and then we enqueued JR, but now it looks like JR is the only thing in the queue. Why is that?
Is it because we dequeued everyone else?
That's right, we dequeued everyone else in the printings, and then they're gone from the queue. So maybe that's not something we want to do. How do we fix that issue?
By saving them first in a variable before we dequeue it.
Okay, yes, I like that idea. Tell me, how should we do that?
I'm
not sure.
Okay, that's all right. Well, we could save them to, we could maybe, as we're dequeuing them, maybe we could add them into an array, and then once we finish building sort of a string, you could just add them back into our queue. Or we could add them to another queue, and then after that we bring them back onto our original queue. Let's do the other queue. Let's say let temporary queue. Let's call it temp new queue. And maybe as we are dequeuing them, and after the concatenation, we just add them to the temporary queue. Right? And we add them to the temporary queue. And because they're dequeued in the same order that they came in, then they will be in the same order for the temporary queue. But we should restore them to the queue. Like we should restore them to the queue, not leave them just in temp. I guess it will depend on what we're trying to do, but let's say in this case, we want to make sure that queue is intact for the printing that we needed to do. So there's one extra step we will need to do here. What is that? Oh, well, what do you think?
Wait, I'm not sure, but could we just loop through the our queue and then put it in the temp queue, and then just dequeue from the temp queue, leaving the other queue intact?
That's exactly right. But we want to dequeue from temp queue and add it back to queue.
So then
we can.
Sorry.
Yep. No, go ahead.
No, you're just doing it already. Like just not requeue, but enqueue back into the original queue.
That's right. So let's do that with while, as long as temp is not empty, then we can say queue that enqueue whatever we remove from the dequeue, whatever we do from the temporary.
Sorry, Alejo.
Yeah.
You have temp inside of temp. Is it supposed to be element?
Oh yes, thank you. That's a good catch. I was enqueuing. Wow, that would have been weird. Enqueuing the queue into itself. And to know that that's actually possible. Okay, thank you on that. Yes. Let's try it out now. Let's run it here. Awesome. Now we see that our queue is still the same and JR is at the end of our queue. Awesome. We've wrote a function that is able to print a queue, and we're not breaking any of the rules, which is you are allowed to remove from the front only, and you can add at the end of the queue. Questions or thoughts about this? I was thinking there might be another way in which we can do it as well, with only one queue. But before we look at that, thoughts? What comes to mind as you look at this, the way that it turned out? Anything. Jonathan.
Couldn't we make temp a queue just like queue, or couldn't we assign queue to temp? So temp
Oh,
temp
that's a
would
good.
be a queue without us actually taking from the original queue.
So repeat that. I think I like your point.
So instead of let temp be equal to new queue, couldn't we put let temp equal to queue?
I see. Let me see. So what you're suggesting is temp equal to queue. I see here. Something like this.
Yeah.
Okay, so we can't really, this will constitute a bug. Let's see it happening, because I think it's a good thought exercise. Let me lower maybe this here, or put it at the top, so you can still see the code. I think this constitutes a bug here. Oh, let's see. Wait, did I save? No, I didn't save. Okay. There is a bug there. What's going on?
Wouldn't we have to refactor the code to put while temp is not empty, then we would put let element is equal to temp.dequeue.
I see. Hold on that. But what's the bug that we're seeing right now, or what's the behavior we're observing?
Oh, well, right now because of the while loop is checking for queue and not temp. Queue is never actually empty.
Okay. Wait, well, hold on a second. It is actually, well, it's never actually empty, but I feel like maybe you didn't express the idea correctly. Because we're dequeuing from queue, but why is it not being empty? Like you can see that, in fact, my computer ran out of memory, and then it says heap, JavaScript heap out of memory. So we get an out of memory error. Oh, in the last lesson when we were looking at the memory, these are the memory addresses in hexadecimal code. So what's going on here? Why is queue never being emptied? Even though we are dequeuing from queue. These are good thought exercises as a whole, not only just queues. Queue is never being emptied. Anyone?
Temp is equal to queue. So basically we still have the same queue.
Repeat that. Yes.
So temp is equal to queue. And since, temp and queue is actually the same thing in memory, it's never really empty.
That's exactly right. So this is another point that is good to revisit, where, so in memory we have a queue. Let's say we have 1, 2, 3, somewhere in memory, and we have queue. We have a variable queue that is pointing to that, right? And then we say, okay, we want temp to be the same as queue, but temp will not create a copy of queue. What that is saying is, if I go back to the code here, it's like, and we're thinking of in pointers, we're saying, oh, okay, I want to create a temp variable that is pointing to queue. And then temp is pointing to queue, and then queue is pointing to our actual queue in memory. queue in memory. So then temp and queue are the same thing. Does that make sense to everyone?
So in this case, will we have to use the new keyword? So let temp equals new queue?
You mean something like this? New, like that?
Yeah.
So we can't, because, so if I understood where you're going is, you just want to make a copy of queue,
Yeah.
right? So the new keyword is when we want to instantiate and we want to create new instances from a class, but it doesn't inherently copy the elements from an already existing instance. We'll need to create a function that does that. But what you're getting at is another good approach, which is sort of what we're doing here, maybe a bit more convoluted. Why don't we make a copy of the queue that we can empty? Okay. I was gonna say, why don't we make a copy of the queue that is a temporary and that is, we're just gonna use it to print the elements, and then we get rid of that one. But I was thinking that that will still require us to dequeue from the original queue, which means we're still modifying the original queue. So that's what we currently have here, which is what temp is. We couldn't, I guess like what I'm trying to get at is that we couldn't make a copy of a queue. If we wanna, that could be another function we could write, but if we want to create a function that creates a copy of the queue, and we're still restricted to the methods of the queue, then that still means that we have to dequeue everything from the original queue to copy onto the new queue and somehow put the elements back into the original queue, which is basically what we have here on temporary. In fact, if we want to create that function to create a copy of the queue, in this case, we could just return temp. Well, and we wouldn't need to pass it over to the, oh, actually, that's interesting. If we want to create a copy, it will be the same idea. We'll need to think about the details. That's a good question. How can we create a copy of the queue? Maybe we'll need, what I'm thinking is we'll need 3 queues to make a copy of a queue. But maybe let's take a look at that next, because I think that'll be a good thought exercise. But other thoughts or ideas here that comes to mind? Yeah, I think to make a copy of the queue, we'll need 3 queues, a temporary and then a copy. Okay, so this is one approach. The other approach that I was thinking about that came to mind as yesterday I was looking at some queue stuff with Joanne, and we saw something, we saw this idea of rotating the queue. And what that could look like is if we have, where is the eraser? If we have this queue, maybe instead of having to have, and then I guess this could be also another approach to create a copy of the queue. But let's say we have our queue and we just want to print it without having to copy it onto another one. What we could do is, what if we know we can only dequeue from the beginning and enqueue at the end. So what if we, oops, no, that's not what I wanted to do. We have 1, we dequeue 1, we add it to a string, and after that, we enqueue it back. And since we're queuing, it goes at the end, it will go to the end there. I don't know why that removes that line. And then we dequeue2. We print, we add it to our string, and then after that we queue it back in. And then we do the same with 3. We dequeue3, we add it to our string, and then we queue it back at the end. And after we have completed after we have done a full rotation, then we have our queue in the same state. Does that as an approach make sense? Like, could be possible? Or any thoughts, anyone? Owen, maybe?
All right, so this is what we should do. We should always have another queue. Could we, does it have to be a queue? Could we just put it in like an array or something like that? Or depending on like what, not having like instantiated queue?
We could have it in an array, but since we're sort of thinking in queue mode, let's just use queues. But, well, okay, so I just want to, before we move from this approach and look at the other one, the rotation approach, did this make sense? How we have to remove everything from the initial queue. We save that into a variable, then we add it into a string, and then we enqueue the element into a temporary queue. And then we need to restore the original queue, and the way in which we do that is we just loop again until the temporary queue is empty, putting everything back onto our original queue and queue. Does that make sense as an approach and how it worked? Okay, I see some nods. Well, Joanne's I see thumbs up. Great, cool. I guess, like, you know, if we think about it, the way in which this is working, if we explore it a bit further, is we just have another queue here. And what we're literally doing is taking elements from one queue, we take it out, we add it to our string, and then we add it onto our temporary queue. This is temp. We have an element, we dequeue that element, we print it, then after that we add it onto our temporary queue. We dequeue the element until we're dequeuing elements until that is empty. We add it to our string and then add it onto our temporary queue. But then the problem that we were facing with that was that our original queue was left empty, and that's why we saw JR in the front of the queue when he will be at the end. And then we said, oh, we need to restore our original queue. So then what we do is the opposite, which is dequeue stuff from here. We no longer console log it, or we no longer add it to anything. So we just do it directly. We enqueue that directly. And they always are going to the end, and therefore we get our elements there. I guess, you know, is the same idea. If you think about it on the rotation, is the same idea. Is like we're just holding the element momentarily while we add it to the string, and then after that we just add it back to our to the end of our queue. But does anybody see maybe a potential challenge with that? With that approach of adding here at the end? Or how, or does anybody have like maybe either a challenge that you foresee there, or an approach on how we can accomplish that? let's do, I'm gonna copy this. I'm gonna say print Q, maybe print Q2. Any ideas or thoughts? Anything really?
Would it be a problem if you added another element into that queue as you're moving it?
Okay, yes, that's right. And why would that be a problem?
Because you're removing things and you're putting it in the back, so that would potentially disrupt the order, I guess.
Okay. Yes, that's not entirely wrong. But also potentially we could run into an infinite loop here, because the queue will never be really empty, right? In that scenario that I was doing, when we're moving elements here, the queue is never empty. The queue always has 3 elements. So then that means that either we can't do it or that we need to change this condition here. Right? So any ideas on how we can do that? Here's a question. How do we know we have completed a rotation so that the queue is exactly in the same order? How do we know, how could we know this, that we move that there, we move this here, then we move this here, and that we're done with that rotation, we don't want to keep going? How could we know that?
So every time you move an element, you could decrease the rotation. Yes.
Okay, but then, okay, so that means we need to keep track of rotations. How many rotations did we do in this case to get it back in the original order?
3.
3. And that's, do we have that number? Can we use that number from anywhere?
The size.
The size, that's right. So let's do that. So let's do rotations equal q that size. And then, as Joanne said, okay, while rotations is greater than 0, if we have a queue of 3 elements, that's going to do 3 times. Then let's dequeue the element and let's enqueue it back. Sorry, I think I removed a line I should have not done. Dequeue the element, we add it onto our string, then we enqueue it back into queue. We're not going to need the temp in this case. We enqueue it back into queue. And very important, as Joanne mentioned, we need to decrease the rotations so that we don't run into an infinite loop. We know that we need to do 3 rotations. And then we no longer need this loop. We no longer have a temporary stack. Sorry, a temporary queue. Now let's try that one out. Let's do print 2, print 2. We're still doing the same queue, which is fellows. Let's try it out. Where's the terminal? Let's lower the code here a little bit. And let's run this. Nice. Let me just make sure that I saved. Yes, I did. Clear this. Great. We see our queue. We see our original queue. After that, we enqueue JR. And after that, we see JR being at the end of our queue. Great. Questions, comments, or thoughts on this regard?
That's better to do that than just doing like while q.size is truthy.
Oh, that's a good question. Yes, this is better because if we do q.size is truthy, that means that we will be modifying the size. We'll be subtracting from the size, and we don't really want to. Modify the original q size. Does that make sense?
Yeah.
That's why we save into a helper variable, in this case, rotations. And to be honest, I didn't know. I learned this. I learned about this yesterday. As I said, Joanne was looking at some Q stuff, and I offered some assistance there. And then we looked at a solution. So some other people had submitted for the problem she was working on, and then we saw something like this. And I guess this is also to say, whenever you solve a problem, even when you don't solve it. But after definitely, you have attempted it on your own, look at other people's solutions. If it's in LeetCode, LeetCode has the solution section. In fact, let me show you here right now. This is a question that maybe we'll get to, that is solved using queues. And then here in this one, the solution is actually locked. But if you go to the discuss tab, you can see that the solution is locked. But if you go to the discuss here, you can see other people's solutions that they comment out here. Also, another tip here: never be afraid of looking at other code that's not JavaScript. For instance, this one is Java, and then they have the solution here. If you look at it carefully, you will start to recognize things that is actually where you realize it's actually kind of similar. For instance, the for loops are exactly the same. Don't be the message there is don't be afraid of looking at Java. Don't be afraid to look at it in Python. If statements don't have curly brackets, but you know what an if statement does, etc. So yeah, that is, this is a trick that I learned yesterday as John and I were looking at a problem that involved doing something like this. Cool. Thoughts or questions on this side? So if we wanted to, very quickly, if we wanted to have a function that creates a copy of the queue and returns the new queue, the new copy, how do we need to change this function to do that? Well, yeah. Any ideas? There's actually, I think we'll just need to change 2 lines. What would that be? If we want to create a copy of the queue. Don't be afraid to just, guess or be wrong. We want to have a function that creates a copy of the queue and returns the new queue.
We
I
had
would
like
maybe.
we had like a temp queue. Like we create a new let temp equals new queue.
Equal new what?
A new queue.
Okay.
And the
Mm-hmm. It's a good first step.
And then like we add we enqueue the element from line 84 to the temporary queue.
Okay. Do we need this this line?
Oh no. Oh, we're not giving we're not returning the string anymore.
No, right, because we want to create a copy. This is a different function. This is to create a copy.
So we can get rid of that one, and then instead of returning the string, we can return the temp.
Cool. Now we have a function that creates a copy of the queue. Copy fellows. Do that, and let's do fellows copy just to see that they're actually different. Fellows copy that enqueue Winter was one of our IAs, also pursued fellow. And now let's print fellows copy. There's also copy is this one. So we make a copy of fellows. I almost spelled a mistake there. And also let's print out both fellows and fellows copy. Let's take a look at that. Ooh, queue.size is not a function. We have an error here. Copy fellows. Does anybody see where the problem might be? I don't have any clue. Print queue, return str. Maybe we have a bug in the print queue function. Let's see. Okay, so here we can see the original queue, then JR was in queued, and then we see that JR is in queued there. So then this is good. This is good. This line also looks good. This one looks good. And then we do copy fellows. Queue.size is not a function. Let's take a look at, yeah, Owen maybe?
It says it's on line 67. The right.
Line 67. So that's this 67. Oh. 67 here, rotation queue.size. I'm thinking that maybe something is changing and something is changing it, and I'm just not seeing it. Yeah, Joanne, go ahead.
Can you scroll down all the way down? I think you're saying print Q2 with like fellows copy. Is that supposed to be copy instead of print Q2?
Um,
190.
oh, yeah, these two lines, right?
Yeah.
Yeah, okay, thank you. That was a good catch. I was not seeing that. What I meant to say was this console log here, and this goes here. I was passing a function to print Q and print Q2. I was passing a string where I needed to pass the actual Q. Thank you.
And I think I'm missing another parenthesis on here.
Yep. Cool. Now let's take a look. Great. Okay. So we see here we queued JR. So then fellows here is that queue with JR at the end. And our fellows copy is the same queue that includes JR, but also with winter at the end. Cool. Does that make sense? Questions, thoughts, ideas there? Cool. So we have a function that is able to create a copy of a queue. And doing that rotation kind of trick. That's kind of cool. All right, so let's see. Oh, we never got to. Let me comment out. Let me comment out these lines here. So we now have a way to copy elements. Queue, like copy the entire queue actually, and we saw that we can add more elements to the copy separately. Maybe I want to keep this console line. This one we can keep there. So okay, if I dequeue something here from fellows, what is going to be dequeued? From fellows, what's the element that will be dequeued?
I guess Joanne.
Joanne will be the queue, right? Because Joanne is in the front of the queue. If we come back here, also let me remove this console log here. We don't longer need. If we come back here, Node.js. This is our queue. Then we enqueue JR. Then we dequeue. Joanne was removed. And we can see that now our fellows, now Owen is in the front of the queue and Joanne is no longer there. Does that make sense? Great. So before we move on, I want us to think about, let's think about the time complexity of these methods. What's the time complexity of enqueue and why?
Constant time?
Constant time. Constant. And if you had to say why, what would you say?
Because we're just adding to the end of the array.
That's right. And I'm not sure if you were there last time, but we talked about the dynamic array, which arrays in JavaScript by default are already dynamic. And a dynamic array is an array that grows or shrinks as needed to fit all the elements. And there we saw that the array doubles internally, doubles in size every time it gets full. So there are some inserts in arrays that are actually going to be linear time, but those are rare, and the more elements you have in the array, the more rare they will be, or the less often they will happen. And therefore we have one constant time operation there. How about DQ? What's the time complexity of DQ? Any guesses?
Is it O of n?
That is correct. O of n, linear. And why would you say?
Because every time we remove from the front of the array or the queue, we have to move everything one step, one spot.
That's exactly right. And just so that a quick visual of that, what that looks like is, do we have? Oh, we have shapes here. It's cool. We have an array here with other boxes inside. Oh, I guess these are the slots of the array. We have, let's say we have 1, 2, 3, 4, 5. If we remove 1, the computer internally will move everything back. Will move everything one slot. It has to shift all the elements. That's why it's called shift. And then that will be, so if this is the cool thing about this, is that I can actually do that. Oh, this is cool. It's even better. That gets removed, and then if I remove all these boxes, not those, then this moves here once, one shifted once. Oh, I guess it doesn't work perfectly. Sorry, let me lock that. Can I grab? No. Okay, but you get the idea. All the elements get shifted over one slot. Cool. So removing an element from the front of an array is a linear time operation. What's the time complexity of peak? Somebody else does not Jonathan nor join. What's the time complexity of peak?
Constant.
Constant. Why is it constant?
Because you're just going to the front of the list. You don't have to look through every element.
That's correct. And yeah, I would just say that instead of saying it that way, I would say because accessing an element by index is a constant time operation, which is what we're doing here, accessing the 0th element or the element at index 0. Cool. Is empty unsurprisingly the same, constant time. Constant. And size same. Great. Okay, so this is a good implementation. This is a fair implementation. But if we implement it with a linked list, you will actually can get this to be linear time. Constant time. If we implement a queue using a linked list, we can actually get the dequeue to be constant time. I think so. I'm thinking actually let's go into that, because I'm thinking about. I was thinking of doing this problem with queues, but I realized two things. One is probably gonna take us long. I haven't solved this problem myself, so I was gonna try to figure it out as we're here, by maybe looking at this, by looking at a solution and then trying to visualize how that works. And what was the other thing? I'm gonna leave it actually up to you. We could try to solve this problem with the rotting oranges. It looks like a really interesting problem. We can do that, or we can look into how to implement the queue with a linked list, which will then let us do dequeue in a constant time. So give me a thumbs up if you want to do the queue with a linked list, or any other emoji if you want to do the problem. Okay, see one thumbs up. So thumbs up if you want to see the queue with the linked list. Any other emoji if you want to try to attempt a problem with us all here. Okay, I see another thumbs up, and I see one vote for problem. So 2-1. Okay. One vote for the problem, 2 for the linked list. We need more votes. Also, this Tuesday is election day. Make sure you go vote. Also, that day we won't have any check-ins. If I have a check-in with you on Tuesday, election day is considered a pursuit holiday, so we won't be checking in. That's Tuesday next week.
Is there a check-in Monday?
Yes. Also, thank you for leading the last one. Or the one before the last one. Yeah. Okay, any other votes for the problem or the linked list? We have 4 people that have not voted.
Did I vote for the problem? This is a.
Yes, you did.
I meant to vote for the one.
Okay. Cool. Okay, so is that the majority, the half plus 1? No, we need one more vote to decide this. We need one more vote if for the linked list to be half plus 1 or a tie, in which case I will have to call. I think Giovanni, Siham, Jay, or Shia, I didn't see your votes.
Wait, are we voting through the participants? I have a thumbs up.
Oh, got it. Okay. No, I guess I should have been a bit more explicit. We were voting through the reactions.
Oh, okay, okay.
Got it. I should use the participants a bit more. Thank you for reminding me though. Okay, since like the linked list one. So, okay, so you remember what I said at the beginning, the queue is really an idea. The how it's implemented under the hood, it can vary. Well, we can do that. Let's do that with a linked list now then. So I'm gonna create a new file here, and I'll be sharing this at the end as well. Let's call this queue with linked list. Also, let me capitalize this file name because excuse me. This has to be .js. Cool. Okay, and before we go into the code, let's talk about what the queue is going to look like in a linked list. So, in this case, we had this queue being an array, right? In a linked list, the queue will look like this. Oh, what did I do? Now, linked list, the queue will look like this: 1 node pointing to 2, pointing to 3. Cool. And we will have a head that's pointing. Wait, that is a bit weird. A head that's pointing to this, and we will have a tail that's pointing to this. So when we want to add a new element, what we will say is when we want to add a new element, let's say we want to add 4. We'll just say, okay, when I add 4, we create a new node, and we say, okay, the tail.next is going to just point to that new node, like so. And then we update the tail to now point to our new tail. So that's when we were adding 1, right? So adding 1, in this case, what time complexity is that? Adding at the end of the queue. What time complexity would that be?
Oh, constant.
Constant, that's right. Now let's think about dequeuing. So for dequeuing, what we will do is actually very simple. We want to, when we are dequeuing, we want to dequeue 1. We want to dequeue 1. So we'll say to dequeue it is really what we're doing for dequeuing 1 is we're saying, okay, let's hold on to here we'll do something like let's hold on to the element. Let's hold on to the element into a variable, and then it will be more something like, well, if I want to be explicit, it's like let's hold on to the element with a variable that's pointing to the element, and then we say, okay, head now is going to be no longer that element. Head is going to be the next element. So head.next, and we updated the head. As this happens, then the head now of our queue is the head of our queue now is 2, and then we have dequeued one. So I just realized that actually the way in which this will happen is we'll do element. What we'll do is we will move sort of the value. We'll copy the value from the head onto a variable, let's say 1. And then after that, we do head equal head.next to update that pointer there. And then once we have this, note that nothing really is pointing to the head anymore. What we're holding on to element is really just the value of the first node, or of the previously the head node. And when something is no longer pointing to an object, in this case a node, then that gets removed from memory, or what is known as garbage collected. What that happens is that then that node is removed, and now we have a queue where 2 is at the front. So what do we think is the time complexity of that? As I said earlier, constant. Thank you, Owen. Okay, so that's the visualization. Let's do it in code. Also, something you should be able to then by now do with the practically closed eyes is creating a node class. Who can guide me to create a node class for a linked list?
Sure.
Go ahead, Owen.
You want to do like class node, so you create the class with the brackets, and then you want a constructor. Yeah, with the parentheses and the brackets. In the parentheses, you want to have the value, or val, or whatever.
Val for sure.
And then you want to have this. Then you want to have this dot value equals the value, which is referring to the parameter in the constructor. And then you want this dot next, which is the pointer, to be. I usually put it equal to null because it's nothing.
Yep. I like that.
And that's pretty much it.
That's pretty much it. Thank you, Owen. Great. Now with nodes, we're going to represent our. This is how we're going to represent our linked list, just with nodes. Great. Cool. So we have that. We are going to have our class Q. Q again. Now our class Q will have, we'll need to keep track of a head, as I said, constructor, ball, and we can have a head. This is that head. Let's start both with null, and we're gonna have a tail. Let's also start with null. Oh, hopefully we can see something interesting in a bit. So we're gonna have a head and a tail, and the methods, no surprise, they're the same. Dequeue, enqueue, peak is empty, size. Gonna have the same exact methods. Okay, maybe let's start with enqueue. So enqueue is gonna take value here. So I described how enqueue would work. Who can tell me what lines to write here? According to what we have looked at, let me close this and put this here. according to the movements of the pointers that I have done here. So how do we enqueue something? Or how do we start thinking about this? Anything really?
Can you start with creating a node, like a new node?
Yep, let's do that. New node equal, how do we instantiate a node one more time?
So you would say new node and then the parentheses.
We pass the value inside. Great. So we have a new node. So that is like creating. Yeah, let's do it. Let's do it visually as we're going. That's like creating. That's like creating the circle. Now we have a node. Right. This represents our node. Cool. So we have the node. Also, let's think about this. So we start with an empty linked list, right? So we have something like this, like head, tails is null, and head is also null. And we want to start creating a linked list. So how do we do this? So we have the new node. Any other ideas?
We could check if there's a head inside the node.
Is there is a head not inside the node, inside of the queue or sort of linked list, right? So let's check if there is a head. What do we want to do? Or how do we want to express this idea?
If there is, then you basically want to reset what the tail is.
Okay. So that will be. So before we get there, that will be. Let's say we already managed to put this node there, and we have something like this, right? And tail is also pointing to this node. So now we created a new node with value 2, let's say. And then you said, then you can keep going.
And you want to add the value to the head.next.
Okay, but so you will think that maybe we need to do head.next equal new node, right? But yeah, sorry, go ahead.
No, I said yeah.
Okay, but we actually want to do it through the tail because the head will never change. Well, the head will change when we dequeue, but not otherwise. So if there is a head, oh yeah, then let's do it through the tail. Tail.next equal to the new node. So what that will do is tail, which is pointing to the first node, connect that to this node. And then after that, we want to say tail is actually this new node. So how do we do that step?
So we could reassign the tail. Is that tail equals tail.next?
Yes, or was the same as saying new node, right? Okay, so that's if there is a head. That is if this is saying if you have something already in the linked list, right? If we don't have something in the linked list, what do we want to say?
Then we want to add a head.
That's exactly right. Where the scenario that we have is this. We created a new node. New node is pointing to this. New node is pointing to this. Then we want to add the head. How do we do that?
So we could do this dot head is equal to no.
Okay. Would that be it, or should we also do something with the tail?
The tail should also equal to new node.
Mm-hmm. So the tail should also be equal to that new node. So we do this, that tail equal new node. And now what we're doing is these two, oops, I keep getting to click out of there. These two are pointing to this guy here. And then after this function finishes, then the new node reference stops existing because new node is a local variable. Okay, so I think this might be it on that regard. We'll see. I kind of have the feeling that maybe I'm forgetting something here.
I think you're supposed to add like the length or something.
Oh, that's a good point. Yeah, so we want to keep track of the size of the queue. So maybe when we're enqueuing, we want to increase it. And when we're dequeuing, we want to decrease that, right? So let's have another place here for that. Let's call it size. Starts as 0. So maybe this condition could be rewritten as saying if the size is 0, then no, sorry, if the size is not 0, then we want to add to the tail. Otherwise, we want to make the new node the head. So size is there 0, and then here we can just increase it. This dot size plus plus. Yeah, plus equal 1 is the same thing. Great. Any questions or thoughts on this part? Okay. Can somebody else guide me through the dequeue functionality? So let's say we have now actually, before we do that, let's say we want to enqueue 2, and let's run our algorithm through. So that will be this line. We created the node, and then we check if there is a head. There is a head in this case. So then this next line says this dot tail dot next is equal to the new node. This dot tail is pointing to 1. That next, so the next property is going to be equal to whatever new node is. I guess new node is, this is our new node. New node. This is pointing to this. So then we're saying tail dot next. So tail dot next equal to the new node. Okay, so we have that pointing there, and then we say tail. Tail now point to this new node. Great. Cool. So it seems that then we have a simple linked list working now here. Then dequeue. If does anybody remember this, sort of the steps visually? How does those steps reflect in code? Owen, maybe.
So we want to I guess we want to point to the head. Wait, no, I'm sorry. Forget it. I'm confused with something. Okay,
So,
yeah, sorry. We want to.
yeah.
Sorry. We want to see if the head is null, meaning like if there's anything in the linked list.
Okay, I like that.
And then if there is, we want to make the we want to set the sorry, we want to set the first element to be. We want to point from the first element to the next element. So what do we have? The head, or yeah. So we want to put this dot head equals this dot head dot next.
Okay.
And then we want to return this dot head dot value.
Okay. Okay, so we have to be a bit careful here in the order in which we're doing the operations, because if we follow this literally, then what you're doing is updating the head. So if we have this linked list, you're saying head is no longer going to point to 1. Let's point to the next one, which is the tail in this case. And then you return this that head that value, but then this that head that value at that point is 2.
Oh.
Right? So we have to review this order or something here.
Oh, so we can do, actually, we could save our, sorry. We should save our head, our original head, to a variable.
Okay.
That's what, and so then we say let original head equal head, and then we make, then we change the pointer from this dot, sorry, then we point to the next value, what we're doing on line 30, and then we return the original head dot value.
Yes. Cool. Here we go. And if there is no head, I guess that, let's say if also we forgot one step here. Where did my size go? I thought I had added size here. No, also, did I do this? The constructor wouldn't take anything there. Okay, and then we want to remove the size, that size minus equal 1. Cool.
You put the size in the node as well.
Oh, that's my mistake. I meant to put the size in the queue. Thank you. That's a good catch. So we reduce the size. Also, maybe in this case, like we could just say here. Why don't we say? This is interesting here, because this question, what we want to check here is if there is something in the queue, or if there's something in the linked list, right? And we could ask that with this dot head. We could ask that with this that is empty. We could ask that with this dot size, right? We can say if this dot size is greater than 0, that's the same thing as saying, do we have something in the queue? I feel like let's do it with this that is empty. So if it's not empty, if the queue is not empty, then let's do that. If the queue is empty, let's maybe throw an error. Throw new error. It says queue is empty. Nothing to the queue. Okay. Great. We have our DQ. What would a pick be? Somebody that's not join or own. What would pick look like? We want to look at the value. We want to return the value of the first node in our linked list.
Wouldn't we check to see if there's a head?
That's an important step, yes. So let's check that there is something. Again, to check that there's something, we could use is empty. We could use the size to see if it's 0, or we could also use actually this that head, right? Okay, so we check if there's a head and
return this dot head dot val.
that's exactly right. Else, let's also throw an error. In case you hadn't seen how to throw errors, this can be something. Q is something, nothing to peek. Okay, how do we do is empty? Someone that's not Joanne, Jonathan, or Owen. Wait, let me see how many people do we have here? Oh, okay, we have 5 of you, five. So either Nilbert or Giovanni. How can we do this empty method? There's a one-liner.
Can you check if the head is equal to null?
Yep. So maybe we could do that like this. Return false, else return true. Does that make sense?
Yeah.
Okay.
You said you do it one-liner?
We could do it with one-liner, yeah.
I think
Yeah, go ahead.
if there's a head, then we return false. I think you're missing the.
Wait, say that again.
You wrote if there's a head, then we return false.
That's right, because that means that it's not empty. If there's a head, we have something inside.
That makes sense.
Well, there is multiple ways in which we could do that. We could check if we could simply do return this dot size triple equal 0. Right? If the size is 0, then that means it's empty. And the approach with the head is not wrong. Also, but I wanted to bring your attention here to this. Whenever you have an if statement that looks like this, that has if something is true, return false, or if something is true, return true, else return false, you can generally just get rid of the if statement and say something like this. In this case, I could say if not head, just return return not head. Return not head will be when there's no head, returns true. When there is a head, it will return false. This is a bit on some unit 1 sort of logic operators. This will return when there is the head. If there is a head, then a head is a node, and a node is a truthy value. And then that's truthy then when there is a head, and negated, that will be false, right? Which means false. The queue is not empty. When there is no head, then this will be null, which is a falsy value, which is then false, and we're negating that. So not false is true. When there is no head, we return true here. So that's another thing there. I guess here, let's do it like this. And size, we could just say, well, return this dot size. I guess size, just because we have the same API on the other one, but we could maybe just use this one directly. But I think I like the fact there's a method for it, not sort of accessing directly. Yeah, Giovanni. Oh, Giovanni, was that a question? Sorry.
Oh, sorry. No.
Okay. So any thoughts, questions here? So I feel like we might have something interesting here to see to wrap this up. Here, let's do this. Do you remember that we had a queue of fellows in this file, right? We did this. So I'm gonna, oh, did I copy it? Yes, I did. So I'm just gonna do that, the same exact thing. I'm not gonna change a single part of it. And our queue should work because we have our queue, we have a common API, which means we have the same methods. So this should still work. And then also, we have, I'm gonna say print Q2. I'm gonna copy this function that we wrote here. And I'm going to paste it here. So we have a queue. This queue is built with a linked list, which is actually just nodes connected, right? I really hope this works. And we're gonna enqueue Joanne, Owen, Jonathan, all of them in our fellows queue. And now, now know that this queue is, under the hood is a linked list. And then after that, we're gonna print it using the same algorithm that we wrote for the other queue, and that should still work. So let's try it out. Let's try print Q2 and put fellows. Let's do this here. Move you around here. If I can move you, there we go. Did I save? Yes, I did. Let's do a less node queue with a linked list. Let's run this. Oh, dang it. Did we? Fellows new queue. Oh, also, I'm not console logging. And it says queue that size is not a function. We have a function here in our queue. Oh, okay. This is interesting. I guess I didn't think about running into this problem, but I guess you live, you learn. So we have a conflict here where we have one property called size and a method called size. Just for the sake of this, I'm gonna rename this size to be length. I can hear a cat. We have a friend in the room. I'm not bothered by it. Okay, so I'm changing that to just length so that, oh, this will still be size. I changed the property to be different from the method, just so we avoid that conflict there. It's something I did not remember at all. Okay, that's the only change. Let's take a look at this here. Dequeue with linked list. And we have our linked list being printed. Let's enqueue JR. Enqueue JR. Fellows enqueue JR. And let's print the queue after that. Let's see what we got. We have our queue being printed, then we enqueue JR, and then we see JR at the end. But the cool thing about this, the point that I want you to take away is that because we have a common API, because we have the same methods, they work in the same way, the internals are different, but we are still able to enqueue without any changes. We're still able to print without any changes, without, we wrote this algorithm to print the queue, our first queue, and that queue was using an array internally, but the methods are the same, and it works exactly the same. Even it works exactly the same, but now we have a queue that's with a linked list, but we didn't have to change anything in here nor here, and it still works. So I hope that serves as helping you realize that under the hood, the thing that we're implementing might be different, but it might be implemented in a different way. But we have the API, which means the methods that an external an external user can use to interact with our data structure. Then it doesn't matter how it's done under the hood as much. Here we see that again, print queue works exactly the same. Even even copying the queue should work. And because again, we're utilizing the same methods, they're acting in the same way, and so on. So I was thinking that maybe one bug this might have is if we dequeue all the elements, we're not resetting the head. We're not resetting the head. So, but that's a minor bug there. Let's reduce our linked list to just 3 elements. So we have that, and then let's do while fellows is not empty. Let's empty the queue. Well, fellows is not empty. Fellows.dequeue. It's like this, and then I'm gonna console log the queue after we have dequeued everything. Wait, hold on. Is this correct? Did I save? Print dequeue2 and then fellows. You know what? Let me just make sure that I don't put print to final. Let's say fellows. Oh, the queue is empty. Final completely empty. I guess I was thinking about when we dequeue. Wait, hold on. So for this, I'm actually gonna look at the internals of the queue. So because I suspect there is something there, I'm gonna look at the inspectors of the internals of the queue by just console logging fellows. And there we go. We see that the head was set to null, but the tail still pointing to JR. This is a bug. This is what is known as a memory leak. That we supposedly we emptied the queue, but there is something there that will still be using that. And actually, this is another bug that this has is if we try to add a new element to the queue, let's see, enqueue here. There is no head. That new element will be made the head there. And then if we enqueue another element, the other element will come after GR because we forgot to make this change. Just so that we see that this is what I'm talking about. So we're supposed to have empty the queue here. To have emptied the fellows queue, right? And we see that when we, when we say empty queue, and we say, let's say fellows, print queue fellows. Right, so if we run this, print queue is then a function of print queue2. We see that the console log, our function is saying us, yeah, it's empty. But when I looked at it internally, then we realized that there's a tail still. We didn't reset the tail. What that means is then that we have this bug. If we do fellows that enqueue. Let me enqueue myself, and then I print the queue. To say Alejo, we're gonna see we see Alejo there. We're still sort of thinking, oh, that's the only thing in the queue. But I said JR is still in there. And JR will come up if we enqueue again. Let's enqueue Nilbert that we had removed. And then after that, let's say after, let's just say Nilbert here. And we're going to print the queue again here. And let's run this. Wait, what is going on here? Maybe I was expecting to see JR now here. Let me see. Let's say console log, not really empty, with just fellows. So not really empty. We see that the queue has, the head is null, but the tail is still remembering GI there. The length is 0 though. So we do, I see. Yeah, I guess like I didn't fully thought it out. So then it's a small bug because we remember GI there in the tail, but it wouldn't pose any more problems than that, because if we think about it, when we enqueue, here's how, when we enqueue the next value, which is Alejo, JR will get overwritten because we're saying if there is no head, then sorry, if there is no head, make the head the new node, which is Alejo, and make the tail the new node, which is Alejo. Does that make sense?
Yeah, I get that.
Cool. So it's still kind of, we should still get rid of this having, even though we emptied the queue, there's still something that's holding the reference to the last node. So what we could do is, if it's not empty, we remove it. Dequeue. And then I guess here we could just say if this that head, if not this that head, meaning that was the last node, let's set this that tail to null. And we can then fix that minor thing there, where now if I save and I run again, we have that now we empty the queue and nothing gets printed. And we say not really this part where we were still saying JR, now that's also null. We fully emptied the queue, nothing is being remembered. And then we add Alejo, and then we add Milber, and then we have Alejo at the front of the queue and Milber after that. Cool. Questions, thoughts, comments on this review on queues?
Thank you for taking the time to show us this.
Absolutely. You're very welcome. I feel like, I don't know, I always think that it's kind of cool that we didn't have to write anything different for print queue. And this function works with both queues because both queues share the same API, they share the same methods. How the internals of the methods work are different. But then we can abstract that away, and if we know what the methods are doing, we have a commonality there that we can rely on. So that is pretty cool. Other questions or thoughts?
Good use of solid principles.
Say that again.
I'm saying good use of solid principles.
Definitely. Thank you.
Like solid is in the acronym.
Oh, solid is an acronym?
Yes.
What does it stand for? I don't think I know.
Like one of them is like S is for single responsibility, and then keeping. It's not just keeping the code dry, but making sure that you don't have to like modify code rather than extending it.
I see. Let's take a I have, this is the first time that I hear about solid principles. Let's take a look. Solid Wikipedia. So for simple responsibility, open, closed, Liskov substitution, interface segregation, dependency inversion. These are some complicated names, but maybe interface segregation. Oh, this is interesting. Oh, what this made me think is also, you see how I was talking about the API of the queue, and the API of the queue is these methods, right? Also, that's also known as the interface. The interface, or how a consumer that wants to use this queue interfaces with the queue itself, is through the methods, through calling the methods. So for talking about the methods of this queue, I could say that's the API of the queue, conformed by the methods, or I could also say that's the interface of the methods. And then what we could do is, with our other queue, our initial queue, we will say these two queues have the same interface. They have the same methods. They have the same API. Yeah, cool. Last minute questions or thoughts? I'll make sure to either push this into a repo. I think that's most likely what I should do. Push it into a repo and then share the repo with you all. Okay. Cool. So if there's no more questions or thoughts, that is it. That wraps up our review on queues. Let me see. Oh, I think I saw some in the chat. Okay. Let me, where is this? Stop recording there.